Here we go, folks. 6.4. This is what we call the discriminant. Now, if you speak English at all, you might be able to figure out what the word discriminant might mean. To me, it sounds like discriminate. So it's part of this quadratic formula here that discriminates between the type of parabola it is, or the types of solutions, right? Now we've seen already that we can have either 2, 1, or 0 solutions, okay, depending on whether they cross the axis twice, once, or never at all. Now there's a piece of this formula right here that will determine whether any solutions are possible at all. And the portion of that formula is this b squared minus 4ac. This is what they call the discriminant, okay? Discriminant. Good thing I teach math and not spelling. So b squared minus 4ac is our bad boy. Hopefully you understand that you cannot take the square root of a negative number. So that's what we're looking for, okay? Now it's always plus and minus this value here. So if this is, say, a 16, right? Square root of 16 is 4, so you'll have plus 4 minus 4. That'll give us 2 answers. Think about what value in here would only give you 1 answer. What value can you add and subtract that doesn't change the value? Right? And then in here, if this was negative, what would you tell me? Right? If you can't take the square root of a negative number, then what the hell does that mean? Well, let's have a look, okay? So remember the a, b, c come from this formula, right? A can't be 0 because if a was 0, boom, what you'd have left is a linear function, and we're looking at quadratic, so that doesn't work. So now we're going to look at this b squared minus 4ac thing, okay? If this value is greater than 0, so for example, plus 16 minus 16, right? It's going to end up giving you 2 solutions, because you're going to go negative b plus that value and then negative b minus that value, okay? And what that means, if you have 2 solutions, it means that it crosses twice. Boom, boom, 2x intercepts, okay? We call those 2 real solutions or rational, whatever. We'll deal with that in a sec. The next question, or next situation, would be if it's equal to 0. So minus b plus 0 minus b minus 0, that would just be the same value. So what we have is just 1 solution, okay? And I like to call that a double root. Okay, it's a double root, and I also like to think of it as a bounce. Why? Because it actually just bounces off the x-axis. If there's only 1 solution, then it has to just touch it once, and it's going to look something like that, okay? The third situation we're going to look at briefly here is if your discriminant is less than 0. Now we've already looked up here that if this is less than 0, you can't take the square root of a negative number, which means you have 0 solutions. Now that would be 0 real solutions, people, okay? And I'm going to get to that in a second. And what that means is that your vertex is above and it opens up, or your vertex is below and it opens down. And then you don't have any points where it crosses the x-axis. Now, your questions are going to be like this. They're going to ask you for the number of roots, or the number of solutions, or the number of zeros. And what you're going to do is you're just going to look at this discriminant and figure out if it's greater than 0, equal to 0, or less than 0. And that will determine how many solutions you have, the nature of the roots, or the number of the roots. The other thing they're going to ask you is the type of roots, okay? The type of roots. Now, that is talking about the different types of numbers. So we have what we call rational numbers, okay? That encompass all your integers and all your fractions and some of your decimals and all your whole numbers, okay? These are real numbers, all right? We also have what we call irrational numbers, which are still real numbers, okay? But they are things like pi, or phi, or Euler's number, or the square root of 2. These are all what we call irrational numbers because they are non-terminating, non-repeating. So non-terminating and non-repeating. Okay, so we have to be able to identify an irrational number. Still, we did it in grade 8, I believe. And the other thing is now imaginary numbers. Now, we don't deal with imaginary numbers, but Let me just quickly show you, okay? Because what we've talked about is that you can't take the square root of -1. It's just not possible in the real world, okay? But because math is kind of crazy and you can get some kind of kooky stuff going on, they have transcendental math, they have imaginary math, they have theoretical math, all of which I have no clue about. Well, transcendental math a little bit. But imaginary numbers are a real part of some of these solutions, okay? Especially if you're talking about things out of this world. So what they've done is whenever you have a negative under your radical, they actually have a value for it. And I'll show you quickly what it is. The square root of -1 they actually call I for imaginary, okay? So if you had the square root of -4, you would call that 2I. Or if you had the square root of -3, it would be √3I, okay? And so that's just in the back of the book when they tell you they might be imaginary roots or irrational roots or rational roots. There you go. Discriminant, folks. Thank you.